What is up? IQ Kid here. Got a shout out to Bucket Team real quick. And with that, let's start with the arithmetic sequences. An arithmetic sequence is a sequence of numbers in which each term is larger than the term before it. Arithmetic sequences can be defined in two ways. It can be defined explicitly, and the formula for the explicit definition is this. A, where n from n equals 1 to infinity, where a sub n is equal to k plus d times n minus 1. Okay, so in this, k is the first term, and d is the interval. I'll explain that in a bit. Okay, and then the recursive definition is a sub n from n equals 1 to infinity, where a sub 1 is equal to k, and a sub n is equal to a sub n minus 1 plus d, where d is again the interval and k is the first term, a sub 1. And this is where n is greater than or equal to 2. Okay, so with this information, let's go ahead and do a few examples. So we're going to look at three sequences right here. So each of these three sequences, or each of these three are sequences, but not all three of them are arithmetic. And so we're supposed to define them explicitly and recursively if they are arithmetic. So let's go ahead and start with the first one. Okay, here's the first one. So in this first one, to determine if a common interval exists, you take one term and subtract it by the one before it. So negative 4 minus negative 7 is equal to 3. And then negative 1 minus negative 4 is equal to 3. And then 2 minus negative 1 is also equal to 3. So using that, you can know that a common interval exists, and in this case it is 3, which also tells you that this sequence is arithmetic. Okay, so step 2 is to write the recursive and explicit formulae. So the recursive formulae is a sub 1 equals k, and a sub n is equal to a sub n minus 1 plus d, where n is greater than or equal to 2. So this is recursive. This next one is the explicit. So the explicit formula is a sub n is equal to k plus d times n minus 1. Okay, so on to step 3. In step 3, we are going to identify the pieces. So in this one, so step 3, we're going to have k, which is the first term, so that's negative 7, and then d is the interval of 3. Okay, and then step 4 is to plug it in. So we're plugging those values into these formula right here, or formulae. Okay, So let's start with the recursive. So a sub 1 is equal to -7, and a sub n is equal to a sub n minus 1 plus d, which according to this is 3, where n is greater than or equal to 2. So that's your recursive answer. So for your explicit answer, you're going to have a sub n is equal to k, which is -7, plus d, which is 3, times n minus 1. Okay, so now let's go ahead and do another example. So in this sequence, step 1 is to determine, again, if a common interval exists. So let's take 3 minus 1 is 2. 6 minus 3 is 3. That's not good. 10 minus 6 is 4. So we know that a common interval does not exist, which means this sequence is not arithmetic. Okay, so that means we're done with that example. So we're moving on to example 3. In example 3, we have 3, 1, -1, and -3 as our given numbers. So to determine if a common interval exists, we're going to take 1 minus 3, get -2, -1 minus 1, -2, -3 minus -1, -2. So a common interval exists, and it is -2, which means this sequence is arithmetic. So step 2 is to write the recursive and explicit formulas. So the recursive is a sub 1 is equal to k, and a sub n is equal to a sub n minus 1 plus d, where n is greater than or equal to 2. The explicit is a sub n is equal to k plus d times n minus 1. Okay. So step 3 is to identify the pieces. So in this case, let's pull this up again. So k is equal to a1, the first term, so the first term is 3, and d is the interval, which is -2. Okay, and now let's plug it in. So now we have the recursive, so a sub 1 is equal to k, which is equal to 3. A sub n is equal to a sub n minus 1 plus d, which is -2, so minus 2, where n is greater than or equal to 2. And then the explicit is a sub n is equal to k, is 3 plus -2 times n minus 1. So this simplified a sub n is equal to 3 minus 2 times n minus 1. Okay, and that is that for the whole arithmetic sequence. Thanks for watching. I hope this helped, and tune in next time for geometric sequences. Peace.